Okay, so this lesson is not too difficult. It's called Redox Reactions. When we talk about redox, it's the shortcut for oxidation and reduction. So reduction and oxidation. Oxidation and reduction is what usually will happen in a redox type of reaction. You cannot have one without the other. So let's talk about the definitions of each one. Oxidation simply means the loss of electrons. It's where a charge becomes more positive. And here it shows us what an oxidizing agent is. It's the oxidizes another element but becomes reduced in the process. Now I know that just sounds like Chinese to you, but I think the best way to explain this is to go ahead and show you how it would work. Look at the definition of reduction, the gain of electrons, the charge becomes more negative, and you can have the reducing agent, which is what allows this to happen. It reduces another element but becomes oxidized in the process. And in chemistry, we have this little acronym which makes our lives a lot easier. You can either choose to remember Leo goes GR or oil rig, and what they mean is less equals oxidation, gain equals reduction. Or oxidation is less, reduction is gain. Okay, so let's look at this. Now, when potassium is by itself, it is not bonded with anything. It is simply an atom. It's not ionic and it does not have a charge. So it would have zero charge. Bromine is a covalent bond and it is not ionic and there is no charge there either, and it has no charge. Now, when you see potassium bromide as an ionic bond, and if you look them up, you would see that potassium has a positive 1 charge, bromine has a negative 1 charge. Let's see what is actually happening here. If you have no charge on potassium, and moving over to the right side of the equation, you end up with a positive charge. What is happening to the electrons? That's what you will ask yourself each time. And it becomes obvious when you look at the negatively charged one, in this case, because you can see how bromine had no charge and now it has an additional negative charge. What happened to the electrons? Well, they were gained. This is a gain of electrons to go from 0 to -1. Now remember that atoms have an equal number of protons and electrons. So if now it has a -1 charge, that means it must have gained one additional negatively charged electron. And because it was gained, well, reduction is gain. So the reason we give you this to remember is because it's hard to wrap our brain around the fact that reduction is gain. It almost sounds like it's the opposite. Potassium goes from a 0 charge to now a positive charge. It has one additional proton, meaning that it has actually lost an electron. And when something has lost an electron, it is oxidation. Oxidation is loss, and so potassium is oxidation. Okay, so potassium is oxidation and bromine is reduction. When it comes to the agent, meaning what allowed for this to happen, the oxidizing agent for potassium would be bromine, and the reducing agent is potassium. Okay, so it's just the opposite. Let's do one more of these. We have sodium, which has a positive 1 charge, iodine -1, bromine, no charge at all. Here, this is an ionic bond, so they have +1, -1, no charge at all, because it is not an ionic bond. So now I want you to realize we are not comparing sodium to sodium. It's the same charge on both sides, so nothing has changed. So that doesn't even apply. It's out of the equation. Now, if you look at bromine, it goes from no charge at all to a negative charge, meaning it gained an electron. When it has gained an electron, that means it is reduction. Iodine went from a negative charge to no charge at all. It lost that electron, meaning it's oxidation now. Now, finding the agents, the oxidizing agent. Now, in this case, since iodine is oxidation, that means bromine would have to be the agent. This is what allowed this to happen. The reducing agent is going to be iodine because that is what allowed the oxidation to occur. Okay, the last thing that you need to know for this lesson, and it's very easy, thank God, we need something easy at this point. We have a compound, and they want us to find the oxidation state of nitrogen. If you look up the oxidation state of sodium, you would see that it is a +1. If you look up oxygen, it's a -2, but there's a total of 3 of them, okay? Meaning you have a +1. We have no idea what nitrogen is. We're trying to find it, okay? And together, the -2 charge of the 3 oxygens would equal -6. What number, when adding all these up together, would it have to be in order for the oxidation states to equal 0 so that this is a stable ionic bond? Well, the only number that could fit here is a +5. So nitrogen is +5. Okay, let's try one more. We have potassium permanganate, but we are looking for manganese. Okay, we know that potassium has a +1 charge. Oxygen is a -2, but there's 4 of them, so together they make -8. We don't know what manganese is. We know that potassium is a +1. So what would manganese have to be in order for all of this to equal 0? There's nothing else it could be but a +7. Okay, now there's an example from the homework that makes it a little bit tricky because what they do is they have a charge on this compound. In this case, what you would have to do, rather than making it equal to 0, you would add them up and make them equal to the oxidation state that's already on this ion. So if I have chromium and oxygen, well, I know that oxygen is a -2, but there's 4 of them, so together it's -8. We know that they have to equal -2, and we're looking for chromium. What number would this have to be in order to get the -2? Well, the answer is +6. Okay? So this part is not too bad. I know you can do this. I have faith in you. You are smart. You are beautiful. And you can do this.